Hello and welcome to Science in the Park. Today our theme is energy in the sun, energy from the sun for today, tomorrow, and yesterday. Our first professor speaking today is Professor Bodart. He has earned a bachelor's degree in science from the University of Missouri St. Louis and earned his PhD from Washington University before doing a postdoc at the University of Florida. And he's taught at Chipola for almost 30 years now.
All right, thank you, Jenny. I'd like to welcome you all to our second episode of Science in the Parks. Today, as was said, we're going to talk about the sun, energy for yesterday, today, and tomorrow. And if you'll remember what we talked about last month, we talked about how at the very beginning of this universe, in the Big Bang, there was a lot of hydrogen that was formed. And in the process of star formation, we had a lot of other materials that were made, things like iron, silicon, carbon, oxygen, all these things that you see around you in our world. And when we think about the sun, we think of about 5 billion years ago that there was a solar nebula that contained all of these materials, as well as a lot of hydrogen really that was left over from the Big Bang. And in the process of gravitational attraction, we found that the hydrogen would compress itself under gravity. All that hydrogen, if I can grab a pen real quick, all that hydrogen would squeeze together. That is, you would have hydrogen plus hydrogen plus hydrogen plus hydrogen in a nuclear reaction that occurs basically because of all the pressure of billions and billions and billions of hydrogen molecules squeezing on each other, and all the heat that produces, gravitational heat. And you would have another element that's formed, something called helium. You guys are familiar with that, in that you fill balloons up with helium and they float up into the air. But in the process of forming helium, you also form a neutrino, which we're not really going to worry too much about in this month's episode. But more importantly, in that reaction, you lose some mass, and that mass is turned directly into gamma rays. Now, the thing that you probably have seen about this is that E equals mc squared, right? The fact that you can get energy from mass if you multiply it by the speed of light. And then c squared is a number that I know all of you aren't familiar with scientific notation, so I'll just put the zeros. I think that's about what it is, but you can see that as this all turns into energy from a little bit of mass loss, you can get a huge amount of energy. And that's what allows the sun to create its energy over the span of about 10 billion years. So we think that from what we've looked at, we think that it's been around for about 5 billion. So we've got 5 billion years left. So what happens once the energy is created inside the sun? Well, those photons, those particles of light energy, which are the gamma rays, travel from the core of the sun where they're created out to the surface where the energy is radiated out to the rest of the solar system. And what we do, or what we know about that, is the fact that it takes probably thousands of years for those photons to get from the core out to the surface and eventually out to us. And in the process of traveling that long distance, they actually lose energy so that they lose energy so that you get other types of light. Now, gamma rays are the highest form of light energy that we know of. But as the protons travel out of the sun, they produce ultraviolet rays, X-rays, they produce the visible light that you all are familiar with, because that's what you use in order to look at things here on the Earth. infrared, radio waves, all of these things are produced as it travels out, and then it gives us the electromagnetic spectrum that we're familiar with here on the Earth. Other uses for the light that comes here, other than providing a way that we can see the world around us, is that we can use that heat energy, and infrared energy is probably the most predominant form of heat, but we can use that heat energy in order to heat things up. We actually, I've seen people use PVC pipes that are painted black, and they absorb the heat energy, and you can actually heat up your water in that way if you're off the grid or something like that. One thing that we have here, because we have a special treat this week with some of our science club students doing presentations for us, is we have Bailey, who's going to come up, and she actually has a way of harnessing this heat energy by making a solar oven. So if I can get Bailey to come up, where'd she go? There you are. I'll give you the floor, or ground, or whatever it is.
Good morning, everybody. My name is Bailey, and I am presenting my solar oven I made. So this right here, I'm actually making s'mores right now for everybody. So this is the solar oven I made. Basically how it works is that it uses the sun with its energy. The sun rays will beat off of this and go into here. And the saran wrap, if you guys can see this, it will trap the heat in here. So you can keep this up in the sun for a little bit, and it will create an oven naturally to cook whatever you put in it. And it's really cool.
Other benefits that we can get with the light that comes here is we actually have things called solar panels, photovoltaic devices, if you want the technical name of it. But what happens there is it actually takes the photons from the sun. They can fix it so that it uses different frequencies or wavelengths of light, and you can actually get electricity that comes out of it. So that's a really good thing. Along with other sorts of things that we can do with energy, or with the sun to harness energy, is the fact that we've got wind and other weather that's created by the heat coming into the earth. And you all know, I think, that there are windmills that spin around, and from that motion inside of a magnetic field, you can actually produce electricity that way. But there are other problems that you get with the sun. For example, the sun also produces ultraviolet rays, and everyone knows what ultraviolet rays are. They give us a tan. Some people use tanning beds, and they use those to make their skin tan. But some of that ultraviolet, some of the more energetic ones, UVB and UVC, that can actually cause skin to burn. You could get lesions. It can cause cancer, and that's another problem. To talk about one of these with a very popular, fun item that you can use is Jared, one of our other science club members. So come on up, Jared, your turn.
So I have a solar UV Frisbee, and the sun rays produce all kinds of colors that when they bounce off of something, you see the color. Like these bricks, they absorb all the colors except for red, which is reflected back to us, which is what we see. So this is our Frisbee. See, it's turning purple because of the ultraviolet rays, which are coming and is being reflected off. Normally we can't see these rays, but since this is absorbing all the colors except for the ultraviolet rays. So that is what we are seeing with this Frisbee. And then as you go back in the shade, where it's not as sunny, it will turn back. It's lighter, so see, it'll turn back white whenever you get out of the sun. So that was my little demonstration.
Okay, thank you, Jared. Now, the last thing that I want to talk about as far as the light is concerned, and then I'll turn it over to some of our other guest speakers, is that there are harms that also exist because of this light that's coming down here. And I know the visible light, it's not that much of a problem, But when you talk about ultraviolet light, then we're talking about things that can actually harm us, because there are 3 types of ultraviolet light. One type is the UVA, which is relatively harmless. That's what we use to tan our skin and for some of the things that Jared was talking about. But the UVB and the UVC is so high energy that it can actually cause lesions and cause the us to get cancer, basically. So there's a problem that we have to correct. The atmosphere does that on its own. We have something called the ozone layer that traps a lot of that high energy ultraviolet light. But some of that, I mean, because of the things we do to our atmosphere, some of that's able to leak in. And on certain days, we have to be careful about what we have come into our atmosphere. And we have to protect our skin. I'm going to call Travis up here to introduce our last student. So let me turn the floor over to him.
Hi everyone, I'm Travis Bates. I'm a professor of chemistry here at Chipola College. I've been teaching here for 4 years. I'm one of the co-advisors along with Dr. Bodart for the Chipola College Student Scientists Association. And we want to thank everyone for being out here today. It's a beautiful day here in the sun. We got plenty of good weather for that. We also have plenty of water and pizza left over. We'd really appreciate if you guys could eat that so we don't have to take it back home. I also want to thank Jenny for doing our introduction, and she's our science club president, and she's done a great job of organizing all of this, and she's done a good job getting students and professors all involved with our Science in the Park series. This is our second Science in the Park series, and we're still kind of working on our format. We have a lot of really wonderful students, and I just want to thank a few of them real quick, and we're going to have one more come up in a second. But we had Bailey Wilson a second ago. She had her solar oven. She came and talked about us. So she's in the engineering major track. That's one of the things that interests her about making the solar oven. She's still trying to decide between like biomedical or mechanical engineering. But what's cool is at Chipola College, we offer all of the prereqs for engineering. We have a really good physics program. We have an amazing calculus program. That we have all these classes offered. Jared was just up here a second ago. This is Jared Holcomb. Jared, what is your major?
Exercise physiology.
Exercise physiology. Jared is very involved as a laboratory assistant here at the college. He's also involved in many clubs here. Wonderful. Yes. And then our third presenter today is going to be Kat Willett. She's going to come talk about UV, the damage to your sun. She's got a really cool activity, and Jared's going to be helping out with this. Kat, what's your major?
I'm microbiology and cell science.
Kat is doing microbiology and cell science. You're doing a great job. So here.
So y'all, we're going to be experimenting sunscreen on UV beads. I have a few bags, or Ziploc bags, we're going to spray and put a lotion on them for. Well, Jared's going to help me out with that real quick. So basically what I'm doing is just putting sunscreen on all the bags and the Ziploc bag is basically going to represent your skin, and it's going to show how much SPF actually protects your skin against the UV rays that the sun produces. So all that's left is what, 30?
30.
However, you'll notice that one of our bags is going to have it's going to be our control bag that we don't have anything on. And that is to show you what happens when you do not put any sunscreen or any kind of protective on your skin. You ready?
Yep. Good to go.
Can you help me get one of them?
Yeah. Which one?
Just any of them. So basically, you've already seen. We're just letting the sun do what it takes course, and they're already changing color in the control bag. And as you can see, the sunscreen's protecting them as best as it already can. It's actually doing pretty well.
Pretty good.
I'm actually surprised.
Okay, cool.
But as you can see, the control bag has all the colors already produced that they're supposed to do. This is what happens when you don't put any kind of sunscreen on. You turn a weird color. Mostly it's usually red. But as you can see, we did a 50 and a 50 a spray and a lotion, and as you can tell that the lotion's not really protecting as much as the spray is. You can already tell, like, I don't know if y'all can, but I can see it from right here that there's more purple in this bag than the others. But now we get to make these cool little bracelets because there's a few kids here and other students. We got a few strings of beads and all that, and we're gonna make cool little bracelets for everybody. But that's the conclusion of my experiment.
Okay, for our final presentation today, we have the wonderful Dr. Amanda Clark. Dr. Amanda Clark earned her bachelor's degree and her PhD from the University of Florida State. She's been teaching here at Chipola College for 13 years. She has taught pretty much every biology course that we offer, and she's currently our anatomy and physiology expert. Today, she's going to come talk to us about the sun, but specifically looking at the process of how plants and life harnesses the sun to power all the living things around us. So, Dr. Clark.
Oh, perfect. I needed a sun. That's just ideal. Oh, sweet. Hey, Jared, you want to come hold this? You're the best. All right. Hold that for me. Hi, how you doing, Dr. Clark? How's it going? Hopefully I won't be too long-winded because I tend to do that. All right, so I'm going to show you a little bit about photosynthesis, and I actually want you to physically get to see it. So I have an activity I'm going to do. It does take a few minutes for the process to happen. I'm going to explain to you what I do at each step, and then I'll walk around, and while it's happening, I get around for you guys to show it. So to review, let's talk about what photosynthesis is. Photosynthesis, besides being one of the most amazing things in the world, and I'm here to tell you that you can ask all my students, I wish there was a mutation out there that I could just go outside and be like, okay, I'm having lunch. And if you don't know what I'm doing right now, come to my biology class. But you do this, that means I'm absorbing nutrients from the sun, and that's exactly what living things do. And the reason why it's one of the coolest things is because everything we eat is plant-based. Let me explain. The meats that we eat plants. So plants are kind of a big deal. And without them, we would not have oxygen. And so they give us oxygen, and they give us almost all of our food. Therefore, plants are kind of a big deal. So how do they do this? The most important thing they need is sunlight. All living things need the sunlight. So our position in the planetary rotation, that the distance from the sun is perfect and ideal. Not too hot, not too cold, just right. So a couple other things make this a very beneficial natural equation. Water. We all know we need water. It's kind of a big deal. It is an essential part of the equation, which is why living things must have water. Plants, humans, everything, all other animals out there. And so the other thing we need is carbon dioxide. So carbon dioxide kind of gets if you want to really underexplain carbon dioxide, living things, other living things besides plants actually emit CO2. And when you emit CO2, that means it's abundant in the atmosphere. And technically it's a byproduct of all my metabolism. All of the things taking place in my body is the result of activities taking place, you know, growth, development, healing, all that good stuff, processing. And so with that, we emit CO2, which we don't want too much CO2 in my system, so I'm constantly exhaling it out. And so are other living things, which is wonderful because plants need CO2. That is where they get their carbon dioxide from other living things. It's a beautiful, beautiful balance of life. And the reason I say that is because due to the power of the sun, that goes right here, because this is carbon dioxide plus water, perfectly balanced for the chemistry folks, just to make sure, balanced. Add sun to this, and the result is sugar. Sugar is what you get from a carrot. So when you're looking at a carrot, it has been storing for that long winter. It's going to live a long time. A potato is storing those sugars. So the fruit is storing sugars. That the whole process of what it has, that things that we eat, is actually the product of them making foods for itself, and it benefits us as well. So that's the sugars. And there are many, many, many levels of sugars. There's poly, mono, disaccharides, so we can get more complex that later on. And then the byproduct is oxygen. Plants don't need oxygen. It's emitted. And that is what I'm breathing, and that's why I'm here, and that's what's making me long-winded, so I'm very sorry. And this is what we call photosynthesis. Because photo means anyone? Light. Photo means light. What does synthesis mean? Of. It's a process, yes, a good way. We like to think it as like a synthesizer. It makes something. It helps us the process of creating something. So using light, we make something. You know what we make? Life, because it really is that important. So I've got a couple things here, very simple. Spinach leaves are really cool. I picked spinach leaves for this activity because they're more reactive, a little bit quicker, which when you have an audience, you want things to go a little bit quicker. So as you can see, I've taken this spinach leaf, and you'll notice it has holes in it. They don't come that way. That usually means there's a bug or someone took a hole puncher. And you take a hole puncher and you make little discs. They actually use the word chads, but you know, it's Florida, we don't mention that word anymore. No chads. So we're going to call them disc. We have little disc. I've taken about 10, 15 of these little spinach leaf discs. And I've put them in a syringe. The reason I put them in a syringe, there's no needle, it's just the actual syringe, is because I'm going to use it as a pump mechanism. Because I'm going to pour a solution in here. I've created a carbon dioxide solution. Very easy. Baking soda. What do we use baking soda for? Anybody? Anybody know you use baking soda? Clean. Yeah, that's the first thing that popped in my head. It's also big for baking, yes. And you know why it's like baking soda, yeast, why those are essential parts of cooking? Helps it rise. How does it make something rise? It's okay. The test is in 2 weeks. You got plenty of time. It creates carbon dioxide, which is a gas, which is why things rise. It's the gas bubbles creating and the material, maybe the yeast, the bread dough and so forth, and rising, and it emits the CO2 in the cooking, and it leaves, and it cooks and it hardens into the shape. So it's pretty cool. So I've just got baking soda and water in here, and made a solution. I'm going to pour it into. I've poured it into here. And what I'm going to do is use the syringe as a way to get rid of this oxygen. If I flood the leaf in a vacuum sealed chamber, which is why I use the syringe, what I can do here at this point is, you'll notice they're all kind of just, they'll all sit here. Let me get rid of some of the air. And I'll come around and show everybody what I'm doing. And what I want to do is try to get rid of as much air as I can. And they're all sitting here at the top. That's because they're buoyant. They're full of oxygen. And what I want to do is flood the leaf into the air chambers with water from the carbon dioxide. So it's got all the carbon dioxide, but that's going in for the Kelvin cycle and all that good stuff. And so the leftover air pockets, I'm going to flood with water, which means they'll start sinking. And what you do, you use this as a syringe. You're trying to get rid of all the air as you can, and you do this, play a little game with it, trying to let the air escape. And what you want is the leaves to be completely flat. But we're trying to get the leaves to sink. And you do this by creating a vacuum over and over and over again until you fill all the leaves in the air chambers with water instead of air. And then what we do, and the part that I'll show you, is I'll put it back into this container, and now it'll just be leaves, a plant leaf that has a lot of carbon dioxide and a lot of water, but no oxygen. Because technically it's already grown and developed, so it has oxygen built into it. And then, but since I have this and this, I'm going to add that. Got plenty of that today. And then what I should get is you can physically have students watch photosynthesis take place. We use artificial light in a lab. Sometimes we can go outside and have one set up there. And what you can see is oxygen bubbles actually form around the tiny little disc, and the leaves will start to float. It is the most beautiful little thing you get to see, and you just created oxygen with sunlight. It is so neat. And we really enjoyed working with students and seeing this. And it's fun to work with hole punchers and spinach. So I'm going to do that real quick and then put it in my chamber and watch you do that. Anybody else want to talk while I put them in my little chamber? Oh, see how they're all floating towards the, or they're sticking to that. And we're doing that. It's really cool. All right. Anybody have any students want to make some comments while I finish this up? Yeah, it is. What is the famous cartoon character known for spinach eating? That's right. Did all of you know that? Popeye. I'm just making sure because the other day I did the Three Bears and I was just a little nervous that my students wouldn't get that reference. So we've created the leaves where they should be falling, getting closer. Now we can take them out. I just want to make sure. I don't think I've ever done it standing up. And again, the syringe works as a vacuum.
Do you want me to hold my finger on it?
We can peg that down. That's pretty good, I think. I think we'll be good. Sorry, I'm gonna put it over here, and then we'll show everybody. Hopefully they'll sync. Want to check on the oven over here? Oh, that looks good.
Do you want me to hold my finger on it so you can...
Me moving is not helping the situation, but so you can see it. And then what we'll do is we'll add the sunlight. There's a lot of sun here. It doesn't take very long at all, and we already see it's already worked. And that's not even technically an alive spinach. Technically it's been in the fridge for a while, a couple days, freshly bought. But that's how quickly it created oxygen. It's pretty neat. And when we use artificial light, it usually takes about 5 minutes. But sunlight is free and golden and lovely. And that is an example of photosynthesis and how amazing it is. Thank you, sun. Woo!
Well, we'd like to thank all of the students and the professors from Chipola College that presented today. We are going to be doing this every single month, the first Friday of the month. So November is actually coming up pretty quick. November 4th at noon at Wynn Street Park. We're going to be talking about forces in equilibrium. And Dr. Bodart, do you have any spoilers you can give us coming up about that?
Hopefully it'll be warm. You can wear your shorts. We're going to play on the swing horsey and the swings and the slides over there. Be fun.
Yes.
Come ready to play.